For our second lab, we were supposed to model the previous lab as a line of charges. So in a sense, this lab is a continuation of the second experiment we had in the first lab. For this lab, we are to find the electric force on the top tape, but we are to model it as a line of charges rather than a point charge. This lab is code-based, so no new experiments were done, and we were tasked to model this new experiment and to find the charge Q on the tapes, and also to find the forces that act on it to make it float. Measurements that we took from the previous lab from this setup was that the length of the pieces of tape was 0.201 meters, the mass of the piece of tape was 0.000201 kilograms, the distance d between the tapes was 0.028 meters, and the magnitude of the gravitational force on the floating piece of tape was 0.00197,181 newtons, and the magnitude of the electric force on the floating tape calculated from the Q found from the first lab was 0.00197 newtons. For this lab, it was mostly code-based, since we needed to use the GlowScript code to model our point charges as a line of charges rather than a singular point. So for my code, I had my constants written out, and then I had my numerical values, where I used Q from the first lab, and I made a function for an E field and a function to create a line of charges. And then for the second half, I kept doing a trial and error to solve for Q again. For the rest of the code, I created two lines of charges, one to represent the top tape, which was the distance d away from the bottom tape. Then I created a for loop that summed up the E fields at the bottom and how they affected the top. And then I had the force was charged by the charge of the top times the sum of the E field on the bottom, and those two created arrows. So the green arrows were the electric field, the sum at each end, point charge, and then the white arrow is the sum of the electric force, when the yellow arrow is the magnitude of the gravity. And this was again based off of the Q from the first lab. This was found after the trial and error, where my Q was 2.713 times 10 to the negative 8 coulombs. And here you can see that the electric force and the force of gravity are equal to each other, as they should be. So another way that we could have found Q was to model the two tapes as thin rods. So using the Q that we found, which was 2.713 times 10 to the negative 8 coulombs, we could model it as the thin rods and use that formula for a rod, which is going to be shown here. And then using that formula, we find that the estimation is 2.53 times 10 to the negative 8. So even that estimation is a little more off than doing the summation. So what if we wanted to use our Q as the charge for the point charge and kind of do what we did in the first lab? So using the formula for a point charge, you find the electric force using our new Q is 0.00845 newtons, which is a lot higher than the force of gravity and also higher than the force electric that we got doing our linear charge summation. So in my opinion, I believe that doing the summation of charges is a lot more accurate because it more accurately models the system. Rather than just being a point charge, it's a collection of charges.